Hello, everybody, and welcome to your series circuit lecture. Okay, bear with me because I'm going to be showing you some actual circuits, and I'm using my webcam, so I hope it doesn't get too shaky on you. But we're going to look at some circuits today, and you'll see I've got some of our circuit stuff from class. Here's my battery pack, right? And I've got a wire connected to a light bulb, okay? And then now this wire is going to go back. I'm going to connect it to my battery pack, okay? And wow, look at that. Look at that light bulb shining really, really bright. All right, now what I have done is I quick pause and I've still got my battery pack and here's my wire going to a light bulb, and now here's another wire, going to another light bulb, and now I'm going to connect it back to the battery pack here. So take a look at this. And here we are. We have two light bulbs. I'm not sure if you could tell, but these not quite as bright as the first one, still shining though pretty brightly. And here you can kind of see the overall circuit. Okay, I know it's a little fuzzy, but you get the idea. Notice right now how there's just one path, right? We have one wire coming out of the battery packet. All the electricity goes through this light bulb, goes through this wire, goes through this light bulb, and then back to our battery pack. And now, through the magic of video editing, I have now added a third light bulb, right? So here's my battery pack. I got a wire going to this light bulb, a wire going to this one, okay? And then a wire going to this one. And now I'm going to connect it back to my battery pack. And here we are. And hopefully you all can see definite change between when there was just one light bulb and when there are two and now three, right? With three, it's much, much dimmer. Okay, so here is our circuit, and you can see there's only one path. All the electricity has to flow through every single light bulb. There's no option for it to go anywhere else, right? So all of the electricity leaving these batteries are coming through this light bulb, and then this one, and then this one, and then everything is heading back. Okay, so let's talk about this. Why do the bulbs get dimmer? Okay, well, let's think about it. First, let's just say we had, to make the math easy, we had 10 volts supplied by our batteries, and let's say that each light bulb has a resistance of 1 ohm. Okay, we're going to make the math easy here. And remember, V equals IR. So in this case, what's the current? Well, 10 equals I times R. And hopefully you can figure this out, that 10 equals I times 1. So I is going to be equal to 10. Okay, so the current going through a one bulb circuit is 10 amps. Okay, but now let's add another bulb. 10 is still going to be equal to I times R, but our resistance here isn't going to be 1 anymore. Each light bulb is worth 1, so 1 plus 1 is 2. So R is going to be 2 here. 10 equals I times 2. So we divide both sides by 2. I is going to be equal to 5 amps. Oh, so there's less current, okay? And as it turns out, if there's less current, remember that's like how fast electricity is moving through, because it's getting slowed down by not one but two light bulbs. So it's getting slowed down more, and when it gets slowed down more, it doesn't light up the light bulbs as bright. And of course, we could do this with the third one, right? So now R would be 3, and 10 divided by 3 is what? 3.3 repeating, right? And so clearly here our current keeps dropping, and if our electricity is not moving quite as fast, that's going to lead to a duller light bulb, okay? The only way I could have two light bulbs and have them be just as bright is if I increase my batteries. If I popped another battery in there, that would make it brighter. But if I keep my battery power the same, if I keep adding in light bulbs, it's going to make them go dimmer and dimmer and dimmer and dimmer. So far we have just been looking at series circuits, okay? A series circuit is where there is only one path. Like we showed before, all the electricity had to go through either just the one light bulb or both light bulbs or all three of the light bulbs, okay? So far I haven't given you any other type of circuits. Even last week when you were just drawing circuits, you only had series circuits. So today we're going to learn a little bit more about those. We're going to draw some, and we're going to do some math. So if I were you, I would pause the video right now and get this copied down, okay? Feel free to push play whenever you're ready. But this is giving you some instructions on how to do the math that we're going to be doing, okay? If you want the total resistance of a series circuit, you just add up the resistances like I did last time. I did the 1 ohm light bulb plus the 1 ohm light bulb to make 2 ohms worth of resistance. Okay, to figure out the total energy used, that's going to be however much the battery is. Okay, and then this we're going to be talking about a voltage drop. Okay, so every single time your electricity runs into resistance, this could be from a resistor or a light bulb, the voltage is going to drop. Okay, so basically it's going to use up some energy, and so the voltage is going to get lower and lower and lower and lower as the circuit goes on. Okay, and actually at the end our voltage is going to be 0, as you will see. And to calculate that voltage drop, you're going to do the current times the resistance of one of the resistors. If all the resistors are the same, then you can just do the current times the resistance times any of them. If they're different, I'll show you how to do this. You're going to do the current times the resistance of that resistor that you're talking about. And I know right now that might not make much sense, but I promise you in a couple minutes that should make sense. So if you don't have that copy down yet, push pause. But if you do, and if you're ready, then we can continue on and actually see some practice problems here. All right, so here's our first practice problem. Let's say we have a 6-volt battery connected to 2 1 ohm light bulbs. First, let's draw the circuit. If you remember from last time, we usually draw the battery. On the left, it's a series of long lines and short lines. We're going to label it with 6 volts. Okay, now I'm going to connect it to 2 light bulbs, and this is in series. Okay, here's a light bulb. Here's a light bulb. Remember, it doesn't matter where on the squares these light bulbs go. They could be both next to each other on the top. They could be on the right on the bottom. They could be both on the bottom. It does not matter. Okay, we're just going to put a little 1 ohm thing there. Okay, so there is a way we could draw that circuit. All right, so first of all, let's figure out the total voltage. And so what's the total voltage? The total voltage is going to be equal to our battery, which is 6 volts. Okay, that was pretty easy. Now let's figure out the total resistance. This is also called the equivalent resistance. Well, our total resistance, we have a 1 ohm light bulb here and a 1 ohm light bulb here. 1 plus 1 equals 2 ohms. Okay, also pretty easy so far. Let's figure out our current. Okay, so if we go back to Ohm's law, we know V equals I times R, right? And if you remember, we can use triangles sometimes with things, right? And so if we want to solve for I, it's V divided by R. Okay, so I equals V divided by R. Okay, so let's take a look at that here. Our voltage is 6, and our R, we just figured it out, is 2 ohms. Okay, so 6 divided by 2, so our current is equal to 3 amps, because that's our unit for current. Great, and now let's figure out the voltage drop. Okay, so the voltage drop, as your note said, is the current times the resistance of one resistor. So I'm going to take my current, which is 3 amps. So it's going to be equal current times resistance of 1. Okay, so here, notice it doesn't matter because they're both the same. So whatever, I can just pick this one. So I'm going to do my current, and I should really put I for current. So that was 3. We just figured that out. Times my resistance of this one is 1. So this first light bulb has a voltage drop of 3 volts. So what does that mean? That means 6 volts come out of the battery, and then at the end of this light bulb, the voltage drops by 3. So here we have 6 volts going in, and if the voltage drops by 3, then we have 3 volts coming out of this light bulb, okay? And then guess what? This light bulb is the same value, so it's also going to have a voltage drop of 3. So if there's 3 volts coming in, and then all of those volts get used up, we're going to have 0 volts coming back out. And as it turns out, we always have 0 volts at the end. So they all get used up in our circuit here. So 6 drops to 3, 3 drops to 0. All right, let's take a look at one more practice problem. Here we go. We have a 6 volt, sorry guys, let it get all focused here. A 6 volt battery connected to 3 light bulbs, but this time they have different resistances. 1 ohm, 2 ohms, and 3 ohms. So first we'll draw our battery, okay? And I like to put them on different sides. It helps me keep them straight. But again, as you know, it doesn't really matter where they go. You can line them up all next to each other. It's fine as long as there's a wire in between. This one is 1 ohms. This one is 2 ohms. This one is 3 ohms. Okay. So our total voltage here, well, what's our battery? 6 volts. Total resistance here, what's the equivalent resistance? That's going to be 1 plus 2 plus 3. Which is 6, but resistance is in ohms. Okay, so you can draw it like that. And then what is our current? Remember, I equals V divided by R. So our voltage is 6, and our resistance is 6. So I is going to be equal to 1. So we have 1 amp going through. And now let's look at our voltage drop. You can't see that. Move it up. Okay, our voltage drop is going to be equal to the current times the resistor of 1. So let's look at the voltage drop here. Our current is 1 and our resistance is 1. Okay, so for light bulb 1, it's going to have a voltage drop of 1 volts. Okay, for light bulb 2, sorry, writing is hard. We're going to do our current, which is 1, times the resistance of 1. This resistance is 2. So 1 times 2 is 2 volts. Okay? And for light bulb 3, we're going to do our current times our resistance, which is 3 volts. So let's take a look at this here. Okay? So what that means is we have 6 volts coming out of this battery. And then it gets here and 1 volt is used up. So how much is left when it comes back out? 5 volts. And then 5 volts of electricity goes along here, and then we come here, and how much is used up here? 2. So we get 2 volts used up here. 5 minus 2 is 3 volts. Okay? And that 3 volts comes this way, and it gets to the third light bulb, and how much is used here? 3. 3 minus 3 is 0. So we have 0 volts coming out of this last light bulb. And at the end of a series circuit, we always, always, always have no volts left. Okay? So that is what you need to know about series circuits. You see how to draw them. You see how to do some basic math. And basically the rest of your assignment this week are to try a couple practice problems which were included on a doc that was emailed to you. So go ahead and go and try those right now.